In the same way, the roads and bridges provide the physical infrastructure that supports our modern existence. Things like the internet backbone provide digital infrastructure that enables us to interact online. Bitcoin infrastructure refers to the necessary building blocks that we need in order to use Bitcoin properly and to make effective use and capitalize on all the potential that it provides. Bitcoin is an amazing technology, and there are many benefits that can accrue to people who use it across a wide variety of industries. From providing tamper-evident logging solutions that can increase the effectiveness of cybersecurity offerings, to improved asset tracking that facilitate better supply chain management, Bitcoin provides a number of benefits across all aspects of our modern world. It's important that we understand the importance of Bitcoin infrastructure because Bitcoin, as an important system, needs to have solid foundations, effective building blocks that can be leveraged by developers across industries in an interoperable way so that everybody doesn't have to reinvent the wheel. What I'd like to do is provide a comprehensive definition of Bitcoin infrastructure, articulate some of the different ways that different people across our ecosystem have started to build out these different building blocks, and then show how Bitcoin infrastructure enables a wide variety of applications and use cases on top of the blockchain. So let's begin. Firstly, what is Bitcoin infrastructure? When we think of the internet, we have the internet backbone, the system of routers, switches, and networking equipment that facilitate the transfer of information from one data center to another, or to residences and businesses all across the globe. In Bitcoin, we have infrastructure related to transactions. This means Bitcoin mining, but also node software, and the software that tracks overlay networks on Bitcoin. I've spoken about overlay networks before, but essentially, overlay networks are the way that people can use Bitcoin to define particular ways to interact in particular contexts on top of particular protocols. So in the same way that the internet started as a particular way to use the phone system as an overlay network, Bitcoin allows you to create overlay networks that facilitate a wide range of functionality. From increasing the efficiency of, like I said, supply chain and asset tracking systems via tokenized assets, to incorporating things like CBDCs, central bank digital currencies that enable a new level of transparency and auditability within our financial system. There are many different applications for Bitcoin overlay networks, but all of them require Bitcoin infrastructure. Bitcoin infrastructure is that set of essential and common services that enable the operation of Bitcoin overlay networks and applications on top of the blockchain. So what are some use cases for Bitcoin infrastructure? What are some things that industries have in common when they seek to build on Bitcoin? Well, that's a good question, and it deserves a thorough analysis of particular use cases. Let's start with cybersecurity. In the world of cybersecurity, we have a need to create comprehensive logging and monitoring systems so that we can be aware of all the activity that's happening on a particular network. The blockchain provides benefits in this regard because it enables tamper-evident recording of information. So when a particular event happens, that event can essentially be registered on the blockchain in a way that nobody, not even the attacker, can overwrite or change. And so by facilitating the capturing of that information and the recording of that information on the blockchain, companies can benefit from increased transparency. But what are the mechanisms that they use in order to capture that information and record it on the blockchain? How can they later go back and prove its existence? Who tracks the information? What are the protocols involved? How are the keys managed that facilitate access to performing operations on the blockchain by the use of tokenized blockchain assets that are used to pay transaction fees? All of these questions lead to Bitcoin infrastructure. Bitcoin infrastructure in this context means wallet software that cybersecurity companies can use in order to make transactions that record data. Bitcoin infrastructure in this context means overlay network node software used to track this information. And SPV, Simplified Payment Verification, Merkle proof validation software needed to ensure that when information is later presented, it can be validated against the original copy on the blockchain. Now let's take a look at another industry, supply chain management. Bitcoin disrupts supply chain management by making it much easier to track and manage assets as they're sourced, manufactured, and distributed through our economy. Overlay networks facilitate this tracking. And in this context, Bitcoin infrastructure means the software that facilitates the operation of different overlay networks. So different companies source their supply chain management software and solutions from different vendors who might have different implementations for overlay networks on Bitcoin. But there's a benefit to everybody involved when these systems are interoperable. Removing the need to reinvent the wheel in this context is where Bitcoin infrastructure comes into play. There's a common way of doing overlay networks on Bitcoin that could facilitate the operation of these systems in a scalable and distributed manner. By establishing a common standard across the industry, the Bitcoin overlay network node software can provide vital infrastructure for these businesses and facilitate standardization. In the same way that GDS standardized the booking of travel across different airlines who might be competitors, the Bitcoin overlay network node software can facilitate a scalable way to operate interoperable systems across vendors and companies, removing vendor lock-in and ensuring that the maximum amount of value can be conveyed across the industry. Supply chain management is one of many examples of how Bitcoin overlay networks can be used to track UTXO-based digital assets that correlate to physical goods. The shipping industry, where parcels move around complicated routing networks and eventually arrive at their destination, is another example of how overlay networks can track and manage these assets. By opening up the standards that are used to define overlay networks and creating interoperable systems, we can define infrastructure that leads to greater adoption, greater investment from industry, and more significant value creation across our economy. One final example of Bitcoin infrastructure is CBDCs. So central bank digital currencies can be defined in a number of different ways, and policies can be adjusted based on the needs of an economy based on the central bank that issues them. The networks that facilitate the operation of these digital asset platforms could be closed and proprietary, defined and executed by different vendors as contractors to various central banks around the world. Or there could be an open network where we define the protocols on top of which these systems operate in a way that is compatible and facilitates different economies doing different things and turning different knobs with their CBDCs. But CBDC wallets and CBDC overlay networks can be implemented in a cross-compatible manner if desired. One way that this could benefit the economy is by creating an open platform on top of which different wallet vendors could compete to provide wallet software for the same CBDC. By standardizing Bitcoin wallets and ensuring that there's shared expectations between applications and wallet software, we can open up the playing field, allowing for different competitors and creating better wallets with better user experiences over time, in the same way that the web opened up web browsers and allowed for different web browser vendors to exist, leading to far better experience over time. CBDCs are another area where Bitcoin infrastructure serves to create additional value and establish its importance across wide swaths of our economy. By enabling a system that allows for different CBDCs to be deployed on a unified overlay network architecture in an interoperable way, and by facilitating wallets that don't require vendor lock-in, we can significantly reduce the friction felt by users as they adopt these systems and establish credibility with large enterprises and government organizations. Bitcoin infrastructure spans a wide set of services, and there are a lot of different components that go into building particular applications for particular industries. But by and large, the importance of Bitcoin infrastructure is in its interoperability, and we can benefit from not needing to reinvent the wheel. For things like Bitcoin wallets, we can create open standards that facilitate cross-wallet compatibility, so that when one company is using one stack or one wallet, they can still do business with another company on another stack or wallet. In the same way that companies had to agree on the protocols and expectations of those who transmit data on the internet, or in the same way that back in the day, rail car manufacturers had to agree on a common standard for railway interoperability, Bitcoin companies need to agree on the standards by which we're going to develop wallets, services, and facilitate overlay network operations. The importance of Bitcoin infrastructure cannot be overstated. Whether you're dealing with supply chain, cybersecurity, or simply trying to enable more transparency in a particular market, Bitcoin infrastructure is something that should be your focus. As the Bitcoin ecosystem continues to grow and evolve, more companies are moving into this space. And as they do, we need to create resources, tools, building blocks, so they can easily get started, and so they can understand what Bitcoin can do for them. And as we, the people who are here right now, are learning, there are certain ways to scale Bitcoin, certain approaches to application design that mean businesses don't need to process the entire network's transaction volume, only the transaction volume relevant to their particular needs and use cases. By standardizing on approaches that promote scalability, we can ensure that as new developers join, they understand the benefits of the industry, and we can scale to meet their demands. If you'd like to get involved with developing Bitcoin infrastructure, participating in discussions around its standardization, and facilitating real-world use cases, I'd like to invite you to join OpenStandards.cash. OpenStandards.cash is a place where developers can collaborate on the next generation of Bitcoin standards. This means standardizing things like, how do you run a Bitcoin overlay network? How do you define a Bitcoin wallet? How do wallets and apps talk to each other? And many other areas. We're open to new proposals, and we'd like to invite you to join.